So everyone should remember this formula. And the left-hand derivative should be equal to right-hand derivative. Then it is. So before going to the first exercise, first we should discuss about the chain rule. Okay. Chain rule means, for example, y is a function in terms of x, or y is equal to f of x, and x is equal to some g of z, z is equal to some h of w will be there. Okay. So otherwise, do one thing. Instead of this x, you can take like v. Here v is equal to g of z. So finally x you can take. So I want to find dy by dx. Dy by dx means y is a function in terms of v, that is dy by dv we can find, into dv by v is a function in terms of z, so that dz, here z is a function of x. So finally we are going to get again dy by dx. Observe here, dv dv cancel, dz dz cancel. So finally we are going to get dy by dx alone. For example, I'm taking the function sine of log of tan of e power x I'm taking. I already explained about this. So here what I want to do is this e power x, whatever the function is there, e power x I want to take as u is equal to e power x. Then this tan of e power x I want to take as v is equal to tan e power x, that is tan e power x value is u. Okay, fine. Log will be there. This log of tan of e power x I want to take as w. So w is equal to log of tan of e power x. What is tan of e power x? V. So finally this sine of this total value I want to take as some other variable like z. Z is equal to, I want to take something. Otherwise, here itself we can write directly. Then y becomes what? Y becomes, shall I write sine of w? Once again. So chain rule means one function is depending on the some variable. That variable again is a function of other variables. See here, y is a function in terms of v. Okay. Again, v is a function of z variable. Z is a function of finally x variable. So we want to find the derivative of y with respect to x. How can we find? With the help of this. This is a chain process. This rule is called, this method is called, this theorem is called chain rule. This is one of the theorem, right? See here, like this example, y I'm taking like y is equal to sine of log of tan of e power x. Is it recording? Yes. So here different functions are there. It is not different functions. It is a single function, unique function in terms of x alone, only one variable. Y is a function in terms of y variable. I want to find dy by dx. For that, what to do here? So actually we can write directly also, but NCRT we cannot write direct answer, so that e power x you can consider as u. Next tan will be there. The tan of this whole function we can consider as v. So v is equal to tan e power x value is u. So finally v value is tan u. Next log will be there. Log of this tan of e power x I want to take as w. W is equal to log v. So this total is w, then y is equal to sine w. See here. So what to do here to find dy by dx? Dy by dx is equal to y is a function in terms of w. First you have to find dy by dw. Again w is a function in terms of v. You can find dw by dv. So dv is v is a function in terms of u. you can find dv by du. Finally, u is a function in terms of x. This process is called chain process, or this rule is called chain rule. So simple. Here see, we can differentiate very easily. Like what is dy by dw? Sin w derivative, cos w. Okay, dw by dv. So w is a function of v, log v. Log v derivative is 1 by v. Okay. Next, dv by du. So v value is tan u. dv by du with respect to u. Tan u derivative is secant square u. Then finally, du by dx is e power x derivative is e power x. This is the answer. But when you observe here, the question in terms of x variable, the answer also must be in terms of x variable. So is there we having any x variable? No. So you should substitute 1 by 1 value. Since we know that cos w nothing but log v, 1 by v nothing but tan u. Oh, sorry, secant square is there. Okay, right. W nothing but log v nothing but tan u, and the secant square. Next, 1 by v means 1 by tan u. Secant square u nothing but e power x into e power x. Again, what is u here? Again, you can replace u value e power x. Again, you can replace v value. V value is tan u. So cos of log of tan u nothing but again e power x. So 1 by tan e power x into secant square e power x into e power x. Like this is the procedure. I give a just example. Okay, one example for chain rule, how to consider the functions, then how to differentiate. I hope that you understood. Okay, in few questions, we'll see the exercise questions are very easy compared to this. Yes, someone asked me. Yeah.
Little doubts.
Yeah, what is your doubt?
Little doubts. Sir, what you have written after 1 by tan e power x, sir?
Here, 1 by tan.
No, sir, down, sir.
Yeah.
Down right side of that, sir. What is that, sir?
This one, okay, sorry. Roughly I have written. Actually, this is example, so that I did not write properly. This is clearly secant square e power x into e power x. Just
Okay.
it is an example, right? Let us see first this exercise problems. Here limit extends to 0 minus 0 plus will define it and it should be equal. Then only the function is differentiable. See, we proved here this theorem 3 is. I told you clearly every differentiable function is always continuous. So here, if the function f is a differentiable at the point C, then it is also continuous at that point. So every differentiable function always continuous. That is the meaning of that, right? Simple. Derivative of composite functions. So here chain rule or composite function will be same. Chain rule or else composite functions. Both will give same meaning. Nothing but, see here, I have taken one example here. What is the mean by that? Like sin of log of tan of, see here sin value uh, value as here some function. Okay, so if I consider here finally the sin w value some other variable like some k something. So here k circle w circle v circle u, the composition of four functions. We can write like this. If I consider finally sin w as some k circle w circle v circle u of x is given by y. Nothing but composition of four function is given the required, because only one variable here. It's depending on one variable. Okay. So either we can say chain rule or else composition. So okay, first question is that. See here. First, before doing the problem, can you tell me what is u, what is v? You can start with u. Bracket value, this function you can try to consider always u. This is u. In this question, this is u. Here, this is u. Here, this bracket value, this is u. Then this is some u, this is some v. Okay, this is some u, this is some v. This is x square is u. Root x is u. Okay, fine. First question, bracket value is u. Then what about total function? Y. Y is equal to sin u. Simple. Next, when I consider sin x as u, y is equal to cos u. Ax plus b as u, then y is equal to sin of u. Because you know, here each and every function, first of all, we can consider the given function as y. For example, first question is that. First, you should take like this, x square plus 5. Let y is equal to sin square x square. Sin of x square plus 5. Then after, you can consider let u is equal to x square plus 5, like that. I'll write each and every step. But when you observe first three questions, okay, we are going to get y is equal to directly function. But when we observe fourth question, there are three different functions. First, second, third questions, two different functions. In the first one is sine and x square plus 5. Sine is trigonometric, x square plus 5 algebraic. Cos and sine, two different. Sine and ax plus b. Secant to tan root x. So that here u is equal to root x, then v is equal to tan of root x, that is tan v. Then finally y is equal to secant of tan root x means v. So this is u. V is equal to tan u. Sorry, v is. So this is u by v formula we can apply. Here product rule, uv formula, uv rule. So quotient rule you can apply here. Product rule you can apply here. Okay, this is remaining two questions, so you can do directly also. Okay, before going to that, I am going to write the product rule and UV rule. That you already studied about the product rule, the derivative of UV. This is shortcut method, UV dash plus U dash V. In the otherwise, we can write like this, d by dx of, if I take u as f of x, v as g of x, then this can be written as u nothing but f of x into d by dx of g of x. The above formula only I am writing here, then g of x into d by dx of f of x. We can write in these two ways. The quotient rule or division rule. Quotient rule or division rule is given by d of u by v, shortcut formula, v u dash u v dash by v square. This is shortcut. Then when we want to write here in terms of x variable, d by dx of fx by gx. Okay, so here this is equal to g of x into d by dx of f of x minus f of x into f of x into d by dx of g of x all divided by g of x the whole square. Above formula I have written like this. So these two formulas we can use in many cases in even OBT also. Formulas are very, very important. One is product rule or product theorem, and another one is division rule or quotient rule or division theorem or quotient, right? These are the theorems also. Theorems they don't ask, but remember that. Remember these two formulas. So in question number 5, we can apply division rule. In question number 6, we can apply UV rule. But in remaining questions, we can apply chain rule. Okay, chain rule. Right, we'll do first one step by step. First question, differentiate the function with respect to x1 to 8. See here, in this question, they do not ask with the help of the first principle. They didn't ask anything. Particularly, if they ask with the help of the first principle, then we can use the first principle. But in class 12, they don't ask about first principle, right? That is belongs to class 1. Okay, question number exercise 5.2. The first question is solution. Let us consider the given function as y. Y is equal to sine of, what is the function, students? X squared plus 5. Okay, now we want to differentiate with respect to x. See here, the thing is dy by dx. Here we know that we can write directly cos of x squared plus 5 into x squared plus 5 is 2x. We can write directly. I have written already 2-3 times, but we should not do like this. If you do in this way, the answer is correct, but you don't get center marks. So for that, what to do here? So again now, let us consider this x square plus 5 is equal to u, which implies u is equal to x square plus 5. Is that clear? Then immediately, if it is possible, we can differentiate. It's better to differentiate. So differentiate with respect to x. What about du by dx? 2x plus 5. 5 derivative is 0. So this is clearly 2x. This is du by dx. Okay. So when I consider this x squared plus 5 as u, what about y? Then y is equal to, y becomes sine u. Am I right? Yes or no, students? This value is u, sine u. Now here you have to differentiate with respect to u on both sides. Okay, on both sides. Then dy by du is equal to, dy by du value becomes what? Sin u derivative, cos u. But don't write here cos u into du by dx, because with respect to u you are doing. Therefore, finally, shall I write dy by dx? They are asking about derivative of y with respect to x. So dy by dx can be written as dy by du into du by dx. When du get cancelled, again we'll get dy by dx. So we know both values. What is dy by du? Cos u. Yes or no? What is du by dx? Du by dx is 2x. Now, but it is not required answer, because the question in terms of only x, answer also in terms of x, but u, you can replace it by x squared plus 5. What does it mean by u? Cos u into 2x. Finally, therefore, what is the dy by dx, students? 2x into cos of x squared plus 5. This is the required derivative. First, so whatever the function within the bracket that you can consider as u, then differentiate with respect to x. Then when you consider as u, the y becomes sin u. This here, y is a function in terms of u. So differentiate with respect to u. So you'll get to dy by du. So after that, therefore by what you have to write here, therefore by chain rule, you can write like this. Any doubt in this question?
No, sir.
Right, now let's go for the next question. I'm going to give eighth question. All of you do this eighth question. Let y is equal to, or given that y is equal to cos of root x. Okay, fine. Next, let u is equal to root x. So then y is equal to cos u. When I consider root x as u, then cos u. Now differentiate y with respect to u. This differentiate y means above. So that is dy by du is equal to cos u derivatives minus sin u. Okay, fine. Next, differentiate u, because u is a function in terms of x with respect to x. U is equal to root x, then du by dx, which implies here itself we can write no problem. Du by dx is equal to 1 by 2 root x. So root x derivative is 1 by 2 root x. So how can you say that the derivative of root x is 1 by 2 root x? Root x can be written as derivative of x power 1 by 2. Then x power n formula you can apply. N into x power n minus 1. So that is equal to 1 by, they are going to get 2 root. 1 by 2 root x, like that. Okay. Fine. Here we got dy by du and du by dx. Therefore, by which rule?
Chain rule.
Yeah, therefore by chain rule, dy by dx clearly equal to dy by du by dx. We know dy by du and du by dx. So dy by dx is equal to dy by du minus cos minus sin u. Sin u 1 by 2 root x. Root x formula, root x derivative. So you can try to remember root x 1 by x. Okay, a power x. So this is dy by dx, but here dy by dx involving on u variable. Okay. So replace u value is root x into 1 by 2 root x. This is also can be written as sin root x by 2 root x minus, like this. Okay. Simple. The bracket value can consider as u, then du by dx, then the function becomes y is equal to cos u, differentiate with respect to u. Cos u derivative is minus sin u. Okay, after that, take the chain rule, substitute the values, and replace u value. That's it. These questions are easy. What questions are easy? First, second, third, and only fourth, fifth, sixth, as well as seventh. It will have more number of steps. And complete all the questions. First, the important questions in this exercise are 9th and 10th question. After that only these questions, right? Because this question is depending on the modulus, and this is greatest integer function. Okay, let us do this question number 4. Secant of tan of root x. Y is equal to secant of tan of root x. Okay, students, this is the function. Now coming to solution, let us take this is equation 1. Let u is equal to root x. U is equal to root x. And v is equal to tan root x. Tan root x, nothing but tan root x value, already it is u. Tan u. Fine. Next. Then what about the y value? When I consider root x is equal to u and tan root x is equal to v, then y becomes secant v. Is that right? This total value is v alone. Final y becomes sin. Now you have to differentiate separately. First, you have to differentiate u. So du by dx, because u is a function in terms of x. Anyone, what is root x derivative? Root x.
Half x power 1 by 2.
1 by 2 root x. Fine. Okay, derivative of u completed. Next, dv by, v is a function in terms of u. Okay, so don't differentiate here with respect to x, because already root x is u. So dv by du is equal to what? Tan u derivative, shall I write secant square u? Yes, we can write. Because v is a function in terms of u, so d derivative of v with respect to u. And finally, y is equal to secant v is there. And dy by dv is equal to secant v. Derivative is secant v into tan v. Okay. So we got du by dx, dv by du, dy by dv. So after getting all this, therefore by which theorem? Therefore by
Chain rule.
chain rule, dy by dx is given by is equal to dy by dv, dv by v is a function in terms of u, and finally u is a function in terms of x. Substitute all values. Here we got all the values. So finally dy by dx is equal to dy by dv secant v into tan into dv by du, that is secant square u, and finally du by dx, root x derivative 1 by 2 root x. So here different variables we have, but left side dy by dx. So we required only the function in terms of x. So first 1 by 2 root x into secant square u nothing but what? Root x. Right, next secant v nothing but what? V nothing but students, in this question, what is v? E value. Tan u. No. V means I'm replacing V. Tan u. The tan of V is tan u. So therefore, finally, the dy by dx becomes secant of tan u is tan of u nothing but root x, tan of tan root x into secant square root x 1 by 2 root x. This is the required answer. So completely I change it in terms of x. This answer already written directly also. Okay. Direct answer, whatever the question they given, other than the product rule and the quotient rule, we can write directly answer. First secant derivative, next tan, next root x. It should follow the order. Okay, it should follow the order. For example, I want to write the solution of seventh question. Can anyone tell the directly solution? If they give like case study, what will you write the direct answer? Is it difficult? Not at all. So you can take y is equal to this and dy by dx is equal to anyone who is a constant. Okay, first your root will be there. Differentiate this root x and next cot derivative, next x square. First derivative of root. What is the root x derivative? 1 by 2 root x. Am I right? So here 1 by 2 root x. Okay, here it is what? That cot of x square. Fine. Next root completed. So 1 by 2 root x derivative completed. Next cot derivative. Cot of x square is minus cosecant square of x square. Then again finally x square derivative is 2x. So here we can, whatever the function they'll give, we can write directly the answer. So root derivative next cot derivative next x square derivative. Right? Can anyone tell the direct answer for this question? Second subdivision. Y is equal to cos of sin x. So dy by dx value is what? Yes. First cos derivative next sin. Cos derivative is minus sin of sin x. Again bracket derivative. Sin derivative is cos x. Like that. What is the derivative of this? Sin. Sin becomes cos of ax plus b. Again the derivative of bx. Ax plus b is a. Simple questions, but you should not write directly like this. So you should take sin x as u, then cos y is equal to cos v sin u. You can try this question number second and third, and we'll go for fifth and sixth. Okay, before that we'll do the question number 6 alone. Question number 6, which is related to the product rule. Then we'll go for question number 5. Yes, what about the question? Cos x cube sin square x square. Right, how many functions are there? 2 different functions. Cos of x cube sin square into x power 5. See here, generally it is not like cos x into sin x. It is cos of x cube sin square of x power 5. Now we want to find the derivative. Actually, we can use UV rule. Okay, we can use the UV formula, product rule. We can find the derivative. Before that, what I want to do is NCRT we can write directly, so that what I want to do, this y is equal to, I want to compare it with f of x into. Okay, what is f of x value? cos of x cube. See here, f of x is given. I want to find f dash of x. To find f dash of x, here what to do actually? So this x cube I want to consider as u. U is equal to x cube. X cube. Then f becomes cos. Okay. Then here the du by dx value is what? X cube is 3x square. And here all of the squares you can find dy by du also. Therefore, by chain rule, dy by dx can be written as du by dy by du by dx. Okay, here we got du by dx 3x square dy by du. What is dy by du? Students, anyone? Partial derivative. Yes. Substitute the values and simplify here. What is the answer? So these questions. Right, let us see that question number 5 and question number 9 and 10 and next class. See, only yesterday doubt clarification, only 2 students are present.